Okay, today we are talking about graphing circles. This is the first of our conic sections that we're going to talk about. And I started off the lesson just by drawing a circle like this. On the board, I said, here's a point. And if I were to graph another point here, and then every other point that I could find that's the same distance from the first point. If I did that forever, I would have all these points right here, and those points make a circle. So this is the set of all points that are the same distance, the equal distance from this point right here, which we are now going to call the center. And instead of saying the same distance or equal distance, we're going to call it equidistant. And then the distance that those points are from the center is called the radius. So that's how you basically define a circle. So then here on our note sheet, we have this fill-in section. A circle is the set of all points in a plane. Remember, a plane is a flat surface that goes in 2 dimensions forever. A circle is a set of all points in a plane that are equidistant from a given point called the center. Any segment whose endpoints are the center and a point on the circle is called the radius of the circle. So any segment, so a segment is a portion of a line whose endpoints are at the center and on the circle is the radius of the circle. And we are going to be working today with this equation for equation of a circle. There are 2 identifying sets of information here. The first is this HK. The values that go here give us the center of the circle. So similarly, yesterday when we talked about vertex form for a parabola, a quadratic, the HK was the vertex. So here this HK is our center and the R value is our radius. Now I want you to notice here that radius is just R, but the equation uses R squared. So if you knew the radius was 5, you would square it for the equation and put 25 here. Vice versa, if you knew that your value at this part of the equation for R squared was 16, then you would know that your radius is 4 because you would square root that value. All right, so we're just going to use this information in a few different ways. This first example says, what is the equation of the given graph? So I have the circle here. And the first thing I want to do is find its center. So I'm going to see if I can find where its horizontal and vertical axes cross here, or axes of symmetry. They cross right here at this point, 1, 2, 3 of 2. So the center is at 3, 2. The radius, I'm just going to count from the center to a point on the circle, 1, 2, 3, 4. So then I just plug these pieces of information into my equation. Remember, the center coordinates are your HK. So I'm going to plug 3 in for H, 2 for K. And then the radius is 4. I'm not just putting 4 on this side of the equation, I'm putting 4 squared, which is 16. Now this next example, we're doing the opposite way. We're given an equation and we want to graph the circle. So remember that because in the standard form there's a minus inside the parentheses, this means take the opposite, because minus means opposite. So here when I have a positive 5, my H value is really the opposite of that, which is negative 5. Same thing here, opposite of 2, negative 2. Now my radius is the square root of whatever number is right here. So it's going to be the square root of 5. Now the square root of 5 is an exact answer, but it's not very helpful for going to count points and graph our circle. So we're going to convert this to a decimal, keeping in mind that when you convert things to decimals, you do lose some accuracy. But we're going to use 2.2 for counting out our radius. So the first thing I'm going to do is locate my center. And then I'm going to count 2.2 in both horizontal directions and both vertical directions. And I'm just estimating here. We're just sketching. And there is a circle-ish shape. All right, on this next section, it says to graph the circle and write an equation for a circle with the center at -2, 3, and 1, 4 is on the circle. So my center is here, -2, 3. I have a point at 1, 4. Now, because this radius is at a slant, I can't just count my grid marks to get to that point. That wouldn't be accurate. So I have a couple options here. I could use Pythagorean theorem if I found this length here and this length here, because that would make a right triangle, and I would be looking for this hypotenuse length. You could do that. What I'm going to do is a similar process to when we saw for the a value when we're working with our other functions. We start by taking our equation and plugging in the things that we know. So we know the center, the HK values. I don't know the radius though. However, I do have a point on the circle 1, 4. So this is my HK, and this is a random XY that is on the circle, and therefore will satisfy this equation. So if I plug in 1 for X and 4 for Y, then the only variable I have left is the R squared, and I can solve for it. So I'm going to plug in 1 for X, 4 for Y. Follow your order of operations, which means simplify parentheses first. And then there's an interesting thing here I want to show to you. This is actually the exact same math as if I had done Pythagorean theorem on this triangle. Because if you look at this length right here, 1, 2, 3, I would square that. This vertical length is 1, I would square that, and then set it equal to the hypotenuse squared and then solve. So whether you saw this as a triangle to solve, or you just saw this as an equation to solve, you'd end up doing the same math. Okay, so 10 equals R squared. So there's two things I want to talk about at this step. The first is that I only need the value of R squared for my equation. So this is what R squared equals. It is 10. So the actual final answer to my equation is this part right here, and for R squared, I'm going to plug in my 10. And that is the equation of the circle. But the other thing I need to do with this is solve for the radius. So I need R, just R to the 1, not R to the 2. So from this step here, I'm going to square root. You can't simplify the square root of 10, so my radius is just square root of 10. Oh, and then we need to draw it. So square root of 10 as a decimal is approximately 3.2. So I'm going to count that for my center. And then try and get that 1, 4 point in there. I am not interested in drawing perfect circles, so if that makes you twitchy, I apologize. Just breathe through it. All right. On the back, I want you to pause the video and just take a moment and read the directions and look at the equation and think about it for a minute before you start listening to me talk about it. So we're being given these equations and being asked to rewrite it in the equation of a circle. And that means we are working towards this form. Right here. What we are going to do is use that completing the square skill, which we practiced yesterday. And I have 3 steps that I want you to write down up here. So here are the 3 steps. So if you want to pause the video in a minute after I talk about them, so you have time to write them down. The first step is to group the x's together and the y's together. The second step is to complete the square for the x's and the y's. And the last step is to move the constant to the right. So if you need more time to write that down, go ahead and pause it, but I'm going to go ahead and start working the problem. So I'm going to do number 1 and then have you pause the video and try number 2. So the first step is to group the x's together and the y's together. Hi, thank you. And then the second step is to complete the square for the x's and y's. So looking at the x group first, my b value is 6. We want to divide it by 2 and square it. And that value we are adding to the x group, plus 9. And then yesterday we talked about how if you add 9 to the left-hand side, to keep the equation balanced, you have to subtract 9. And we're going to do that same thing for the y group. The b term is -4. Half of that is -2. -2 squared is +4. So I'm going to add 4 to the y group and subtract it on the outside of the group. And now we want to write these trinomials as binomials squared. And we mentioned a shortcut yesterday that you could use these values. X plus 3 squared plus y minus 2 squared. And then -12 minus 9 minus 4 gives me -25. And then alternately, if you don't want to use this 3 and this -2, when you're at these groups, you could just cross what multiplies to 9 and adds to 6. What multiplies to the last term adds to the middle term. You could use these values. Okay. And then the last step is to move the constant over. We do that by adding it. Opposite of -25 is +25. And so then we have this equation here. And this next sentence says to identify the major parts. That means the center and the radius. So the center is -3, 2, and the radius is the square root of 25, or 5. Now, you pause the video and try number 2 by yourself. All right, here is my work for number 2. If you want to pause it so you can check yours, but otherwise this is the end of the lesson. Here endeth the lesson.